We are going, so this is Bill from Diamanti. You met him earlier. And I guess people are going to be trickling back in the room, but I'll walk the hall and I'll push them all back in. And just out of curiosity, is Michael here? Oh, hi. Yes, you are here. Okay. No. You can go up right after Bill. But do you have slides? Where are they? I was what? You did to me? Okay, then I will find them. Okay, great. So, hi, Bill.
Hi.
Thank you.
Thank you.
There you go.
I'm really excited to be able to speak in front of everybody, and part of this is that old saying about if you're the smartest person in the room, then you're in the wrong room. I'm definitely in the right room because you guys are asking great questions. I feel like the dumbest guy in the room here, so even though I'm going to be telling you about some things, I feel I have a lot more to learn from all of you. So, please come talk to me, and hopefully I can learn about what you're doing as well. I'm talking about sort of enterprise-grade applications and bringing those to Kubernetes. And that's because I've worked for 25 plus years in the enterprise area of traditional application database, storage stacks, and there's a lot of companies that are making that transition. So if you're in the cloud native space and you were born cloud native, it may be less relevant to you, but I'm going to make the case that it is relevant. There's 20, 25 years, 30 plus years of knowledge that was born in legacy enterprise, and legacy sometimes gets a bad word. There's a lot to be learned and a lot to be borrowed, plus people in your organizations are going to be comfortable with some of these concepts. They've been using them, they're using them today in the legacy application world, and if you can show them how you're doing that the same way in the cloud native world, they're going to have comfort with that, and you're going to be using the same language. So specifically around storage, I'm going to talk about copy data management. Copy data management is using snapshots or clones and replication to get data around and use it for other purposes, whether that's data protection, disaster recovery, or to process in other applications. And it's been done for at least 20 years, but 20 years ago when I got into storage, volume managers, local volume managers on hosts were doing split mirror copies, and you would use this in a Solaris environment to take a copy of a database and do something with it, back it up, et cetera. So you'd split off a mirror, and then you'd resync the mirror later. As disk arrays, as SAN arrays got smarter, the same technologies immediately moved in. They borrowed the local host techniques, and they moved those into the SAN. And so in this case, I'm just showing a mirror device with a third mirror attached, but those could also be more space-efficient RAID, et cetera. But the concept was full clones that got moved into the storage arrays, and those full clones were used to as the source for data replication, as test, backup, et cetera. And then snapshot technologies, which were invented a long time ago, but really came to life more recently than just the full mirroring. And this is a generic slide. There's lots of different snapshot technologies, and there's ones that are optimized for performance, et cetera. But the concept is you use a snapshot maintains the changes between the state at the time of the snapshot and as data is added. And it somehow recombines those depending on where it's stored into, you have the current data and you have a past image of the data. And that really made space efficiency possible and a lot more dynamic and agile use of copy data management in a legacy system. So, still talking about sort of the legacy background, such things as disaster recovery. This was pretty common in the enterprise 20 years ago when I went to my first storage company, when I left a software company. And full clones in this case, it was at EMC at the time, and then they would replicate those. And it wasn't very agile because the replication would take some time. The full clones initially didn't have a quick way to catch up, and then that technology came, but this was still about 20 years ago, where the next clone would be differences from the last clone. And so you start to get some agility with this. But this was pretty typical. To get data to another place, I took a point-in-time copy, and then I had some background process that could take its time. But they've also been using this for other things, like data migrations. And by data migrations, that doesn't necessarily mean from application A to application B, but if I'm going from version 5.0 to 6.0 of an application, I can take a copy of it and then run my upgrade process. I've never touched the original. If my upgrade process fails, I can go. And this is a variation on test dev, right? So I'm testing by taking a snapshot or a clone. I do all of my application upgrades, and if it looks good, I can either repeat that the last time or whatever, right? But this became the default way of doing things in the enterprise, is I'm going to take a snapshot, not to roll back to if something screws up, to do the actual work, and then I abandon the original volume if I'm happy with the results. And then there's the test dev case. Take real application data and hand it over to the test team so that they can cycle on it, right? So instead of having a fake database with a bunch of downloaded Wikipedia articles, I have my real data, and I can start to discover issues with the schema, right, or with the data definitions, because I'm putting real data into that. So very important, and again, this has been going on for 20 years. It's much more detailed, and everybody's been building their own. It's mainly scripted, and then there's, over time, automation has come along from the storage vendors or from companies like VMware to help with some of this. So up until recently, Kubernetes didn't have any of this, right? Kubernetes started with being able to run the apps, but there was no concept of this. You know, there are some, as mentioned in some of the earlier talks, there's persistent storage and there's some in-tree and some out-of-tree, but it was all vendor-specific or platform-specific, storage platform-specific way. There's some in-tree plugins for out-of-tree drivers, so Flex Volume is a good example of that. Diamanti was the original contributor, as mentioned earlier, for Flex Volume. But again, there's this sort of not general aspect to storage and how to deal with copy data management. So copy data management was do-it-yourself, much like the earlier days of enterprise, where there was no standard way to automate it. So what you did was you looked at your app, you looked at your storage and the features of the storage, and you scripted around it. How do I invoke a snapshot? How do I tell the application to freeze before I do that? All of these things were sort of bespoke or hand-developed for your environment, very application-specific. And as I said, with 1.12, we started to see the beginning of snapshots, and they continue to evolve in 1.13 and 1.14. So snapshots are now a part of Kubernetes. But it's the concept of the snapshot. Since the storage is still external, Kubernetes is not doing the snapshot. It's invoking the snapshot, and then it's up to the storage to do the right thing. So as you go down this path, and if you do want to start using copy data management techniques, you have to remember that these are offloaded to the CSI plugin. So it's allowed for the CSI plugin to do nothing, right? You can have a snapshot and you call the snapshot, and the snapshot could be a no-op because they don't support snapshots yet. So if you're working with your infrastructure people, if you're working with a cloud vendor, you need to know what happens when I invoke these, right? So it's not just, oh, Kubernetes does it now and it'll work. And sort of the same story is that each storage solution must implement these pieces. And because all of the snapshot technologies have different, slightly different things that are going on the back end, it could mean different things. Is it space efficient? Is it, you know, if it's not very space efficient, what if I take a lot of snaps? Is it going to overrun my back end? And if it's on premises, if you own the equipment, you can't necessarily recover from that. You know, I filled it up. What do? I order some more. So anyway, that's the case where you need to understand what's going on in the back end. If it's a public cloud and it's not space efficient what you're doing, then you get a big bill, right? So it's just very important to not just think of Kubernetes as an abstraction and I don't care what's going on with the storage when I invoke these new things that it's delivered. So that's just really important to know. But, there's benefits. Now I can do a lot of these use cases that have been going on in the legacy side of the house, and I can transform them into the cloud native side. So these slides are I put a little cute wiggle of the title just because the slides look identical. You wouldn't know if I push the button here in between. So let's examine a case where I've got data in a cluster. It could be a database, and it's running on pod A of the production cluster. And it's using a volume. And I'm stressing here a full volume as opposed to a snap, which we'll see in a moment. So a typical DR site with backup would, you would take a snap, and hopefully a space-efficient snap on the production site, and then use some sort of periodic replication of that to get it over to the remote site. This could be built into a SAN, it could be built into SDS, it could be, if you don't have any of that, you could manually do this with a tarball and send it, right? But that could all be done as a pod with its own little application written into it and brought fully, or I should say at least partially cloud native, because it's declarative and I've checked it in and I've got a pod that will do this for me, right? So it doesn't really matter how I get the snapshot over there, but that would be done. And then of course I've got this snap that I can now, either full or space efficient snap, that I can connect to my backup pod and use whatever backup technology I want, right? Whether it's a traditional, tar to tape, or maybe I'm using some third party, but we can do that. And this is just a traditional DR use case with traditional storage and traditional apps, but this can all be done with pod specs and putting this together in a Kubernetes environment. And it's easily explainable to those teams where, like, you've got a database administrator, he knows how this is done in a legacy environment. Very comfortable with it. They've been doing this for, like I said, 20 years. And so if you're saying, hey, I'm doing the same thing, you don't have to say, don't worry about it. You say, hey, this is what we're doing, right? We're doing the same thing that we've done before. We've translated it into a native language, or to a modern language and a modern way of doing things. So very straightforward. You notice how similar these slides are. Test dev is the same thing, but we can do test dev. Typically customers are going to have a test cluster versus a production cluster, right? You can mix test and prod. We love to tell our customers, you can be more efficient and mix test and prod, but if you have security concerns, you're going to split these out. Or even just, recovery from, I've done something on test, I've done it wrong. So it becomes a very similar thing, right? And whether I use space-efficient snaps or not depends on how much data I'm changing. There's a lot of variables here. Oh, and by the way, I wanted to preface this. When I talk about volumes here, this is actually a stack of a volume at the storage layer represented by a PV in Kubernetes with a claim on top of it. So it's the same stuff that we've been talking about earlier today. It's just a lot to fit on a slide if I put it all there. So, and you can optimize this. You can potentially delete these space-efficient snaps if I'm not going to be moving lots of data each time. Production data for test dev, maybe you do this, once a version, right? I've got a production version of my data. My test dev doesn't have to be refreshed every day. I just need a version that looks like, with the right schema and the right capacity, right? You don't run your tests on 10 gig of data if you have a terabyte database. You want a terabyte of test data. So you can use this space-efficient snap, get rid of it. Next month, we'll refresh it from scratch. And finally, an important thing with, GDPR, with lots of things is personally identifiable information, PII for short, and it's anonymization. So this last slide that I showed you, in a lot of applications, I'm not allowed to do that. Those test people are not allowed to see the various personal information that should be secured and kept in the production system. So we have to look at a variation on the theme. is that within the production cluster, we take that snap. We may create a full volume of it. We may be able to use just a snap depending on the storage technology, the efficiency, how much data we're changing. And then we have a PII cleaner pod, an anonymizer app that runs within that secure namespace. So I'm not, if anybody who has access rights to pod A somehow gets into pod 2, they're not getting anything they don't already have. And that anonymizes the data, either directly on this volume or on another volume. And from there, you use the same techniques to put the anonymized copy of the data and then make one or more snaps for use by test dev, for use by other data mining tools, whatever it is that your company wants to do with the PII data. Again, everything that we see on the lower half of the screen is stuff that's been done for 20 years plus in the enterprise, and your end user customers in the legacy space are familiar with those techniques. So if you can leverage those, you can sort of ease their on-ramp into this new container world, because to them, change is fear, right? And you can show them how much it isn't changing. Oh, okay. Just a wrap up of a couple things. There's key advantages for cloud native storage over enterprise storage. It's the repeatable declarative storage management, right? This gives you, via APIs, the ability to just do things in a much more declarative way and move those into the realm of the app developers. This is where what these vendors are doing today and what you guys are doing in adopting cloud native storage is an advantage over what's been done in the past. And finally, in order to compete with traditional storage, we do need that declarative, access, right? So what the developers say needs to go all the way down to the storage, and support for things like availability zones, et cetera, right? It needs to. We have this concept within the storage world with replication between on-premises storage models, and we need to be able to mimic that in a cloud-native way with availability zones. And then quality of service, which they've enjoyed in that world as well. You need to be able to pull that forward into the cloud-native world. So if you can do all of these things, you're giving your customers more than if you're not, right? So as professionals, as technologists delivering to app developers, be on the lookout for all these things. And thank you for letting me go over.
My name is Michael. I'm a DevOps architect in Sopra Steria. And I'm going to show you how we were bad at handling the backup on Kubernetes. Because as soon as you start to run some workload on Kubernetes in production, the question is, how do you manage the backup? And we wanted to be honest with you, we wanted to implement something quick and dirty to have it working. But quickly, we meet some limit. And what I want to show you is like a journey of the backup process in Kubernetes. And we try plenty things, many bad. And the goal here is just to show them and why you should not do them, by the way. So Sopra Steria is a digital and service transformation company. It's similar to some other companies that you probably know, like Capgemini, Accenture. We have a lot of big customers like banking, government, and so on. And Kubernetes was the tool that we dreamed for long years without having it. Because we have some contract with many, many apps, and we often have to resuscitate them. Because we are big, the size matter. We can reduce the cost because we are big. And of course, we have all the benefit of the DevOps process. And for other reasons, like the ability to share the tool between teams, Kubernetes was a great fit. So the adoption of Kubernetes in our company is kind of recent. It's 2 years. but it's really accelerating. And we are putting a lot of things on Kubernetes, especially our env dev, but our production of are also going to Kubernetes. So mainly we use OpenShift, which is a Kubernetes distribution of Red Hat. We do Kubernetes, we do OpenShift on AWS, on-premise, and also on Azure. We use EBS, GlusterFS, Safe. We run some workload like MongoDB, Postgre, MySQL, Oracle, Elasticsearch, and usually our cluster is about 50 nodes, so they are small cluster. But we are not going right now on the very, very big cluster like 2,000 nodes. I think we're not completely ready for that. So this is the pyramid of data, and it's easy to understand. At the lower layer, you have all the file system of the physical layer. A layer above, you have the etcd, which is describing your whole cluster. And then, at a level, again, higher, you have the namespace, the resource, the secret, the deployment config, the service, and so on. And at the end, the business data, the content of the database. So the question that I'm going to ask you, in this pyramid, what are you going to save? What do you want to save? Do you want to do your saving here, or do you want to do the saving at the top of them? So we went to the conclusion that usually we just don't want to save this layer. It's useless most of the time. So our first approach was what I call the old way. We save the bottom of the pyramid. So what we did, we built some bash script, a very dirty bash script with AWS CLI, and we used the AWS API, and we just did the snapshot on the set of volumes that AWS was managing. So it's really easy. The advantage of that is really easy. You just have to save the volume. Simple as that. You have a bunch of EBS and you just make a snapshot. But to have it working, you have one thing to do to make sure it's consistent. You have to stop the cluster. So I don't know if you realize the consequences of this. Stopping a whole Kubernetes cluster of 50 nodes, or sometimes bigger, is dangerous. You're not 100% sure that everything is restarting, and you're going to have some serious SLA problem, because some of our cluster are multi-tenant cluster with many customers coming from different countries, and they don't accept the application stop. I don't know, something like midnight in France. Midnight in France is okay, but midnight in France, it could be 10 o'clock in USA. And in USA, they don't want to have the cluster stop at 10 o'clock. So this solution, we had to get rid of it. Another thing that didn't work is it was extremely hard to rebuild the complete cluster, because the number of nodes were always changing and the volume attachment were always changing. So it was a real challenge to rebuild that. So we give up this solution. Then we went to another solution, which was using Lambda. Everybody know what Lambda is. I guess you know. It's a way to execute code, but on the AWS infrastructure. Usually you write it in Python language, and then it do exactly the same thing, but only on certain type of volume we were able to to identify which volume, which EBS we wanted to save. So we did that using the tags to choose the EBS properly. And we were happy because the Lambda is not a SPOF, it's not a single point of failure. And it worked well, but it just worked on AWS. We didn't have solution for on-premise, and it was not the same solution for Azure. The problem also was the fact that some databases are not supporting very well hot snapshot. If you do a hot snapshot on a database EBS, then how are you sure that this database is going to restart in a good way? Because there could be some read-write operation on the EBS, and when you do the hot snapshot, you're not 100% sure that you are in a consistent state and sure to restart. I must say that in some of our experience, like MySQL, we never meet any problem. But for an Elasticsearch cluster, doing a hot snapshot could be sometimes very, very dangerous. So one solution was to stop the database and then doing the hot snapshot. But then the consequences was on the Lambda expression. We had to orchestrate the workload on the Kubernetes cluster to say, okay, I stop the database, I do the snapshot, and then I restart the database. But then your code, your Lambda code, is extremely spaghetti. It becomes hard to do something clean with that. And of course, we still have the problem of multi-tenancy because we have to do that for everybody. Pardon. So we try something else again. Then I'm not completely proud of this one. This one was just ask every team to do what we call a port forward. I think everybody knows what's a port forward. It's when you're doing a port forward on Kubernetes, it lets you access the service in localhost. So every team can manage its own cron server, and in the bash, the bash say, okay, do a port forward and use utilitary like a pgdump and do your backup stuff. But then the cron server become the SPOF, because if the cron doesn't work, the cron server stops to work, then your snapshots are not going to be saved properly. They are going to be stopped to be produced. The port forwarding stuff was fragile, of course, and you have two systems to manage. Now you have the kube system and you have the cron server system. And especially, you have some secret sharing challenge to manage, because all the secrets that are on the server, on the Kubernetes, has to be reported to the cron server. And it's hard also to share the receipt, the blueprint of doing a snapshot. So we tried something that was not too bad, was doing a cron job. A cron job is like a cron, but you execute it on Kubernetes. So you build an image with the client for the database, like pgdump, mongodump, and that thing, and then you run the cron job with that. And then you solve the problem of the secret sharing, because usually the cron job is executed on the same namespace than the application, than the database. Yes. And there was no SPOF, because you execute that on Kubernetes, so Kubernetes is not a SPOF. But we still had some issue. It was very hard to monitor for compliance, so it's hard to know who's doing its backup properly and who's not doing. We still have a lot of maintenance of the code, and it was hard to get it right to know, because you still have to implement all the snapshot retention policy, and that could be a challenge as well. So we try Kanister. We start to evaluate Kanister. Kanister is a Kubernetes native data management framework, so it lets you share some receipt, some blueprint of how you save a database. And then you can share it across different teams, across different namespace. But the main issue here was to share the secret. So I'm running I see that I'm running out of time, so I just go to my last stop. So our last stop now is on evaluating a commercial product specialized on the snapshot, which is Kasten. And it may fit a lot of our requirements, like it's easy to use because there is a very reactive and efficient GUI that lets you see your whole backup. It proposes you some good solution for your retention policy, for your encryption. And it captures not only the database, but it also captures all the Kubernetes resources. So this is our last stop for the moment. And I have finished my journey.